Today we're going to look at some of the basics of technology. We're going to end with a couple of short sections where I look at the, let's say, both ends of the current spectrum, which is challenging for X-ray systems of all types. We look at some images made from some of the latest LED technology, which is obviously very thin materials, very thin wires, and all of the things that test the, let's say, the low power resolution capability of systems. And we're going to finish with some images of IGBTs with large copper ground planes in them, which test exactly the opposite end to get good resolution and good images at very high power. Please, if you have any questions, type them in while you remember, and we'll pick them all up at the end of the presentation. But please, I would advise you, if something comes into your head, just type it down, and that way you'll have it at the end. And hopefully we'll be able to give you some reasonable answers. Well, the wonderful X-ray technology that I've lived and breathed for almost 20 years off and on now has been around for over 100 years. Anybody who knows the history of Mr. Röntgen and some of the very early medical stuff, which unfortunately people didn't understand radiation safety in those days, so some of the people who were experimenting in it and some of the subjects suffered dramatically. Thankfully, we're a long way from that now. We got into X-ray as an electronics industry in the 1980s. I don't know if anyone who is listening is old enough to remember something that was affectionately known as the fine focus black box. It actually had a thermal printer to produce its images. That gives you some idea of context of the time. And a lot of those early systems, they took parts from the medical X-ray machines, because obviously there are a huge number of medical X-rays out there, and not so many, at least in the early days, of electronics. So specialist parts like the tube and the image intensifiers weren't developed specifically for us. The guys stole them from, well, they didn't actually steal them, but they used the same technology that was already there available in the medical industry. This caused us one or two issues, which I will come on to a little bit later in the presentation, but basically at least it gave us the ability to look inside circuit board assemblies and see things that before we were not able to see. There was also a big growth of inspection in casting and machine parts at the same time. Obviously, these require a lot more power. So in themselves, they produced a lot of other challenges. These very early machines were actually an X-ray machine put inside a large room, and the whole room was lined with a large quantity of lead, and the machine was driven remotely from outside the room. So a lot more sophisticated than even our high-end electronics machines. For the last 10 years, things have moved very dramatically in X-ray, as they have really in obviously the whole of the electronics industry. Things have got smaller and smaller, thinner and thinner, harder and harder to see. We have the now wonderful term BTC, bottom terminated components. Obviously, if the joints are hidden from the view of the human eye, they're also hidden from 2D and 3D AOI. So X-ray is the only means by which you can do any kind of joint investigation at all. And obviously, as these things become smaller and smaller, heat becomes an issue. Where you have a void, you don't have heat transfer. So if you have a pad which is transmitting heat, like the center pad on a QFN, and 30% of that pad is void, then you're only going to transfer 70% of the heat that you were expecting to transfer out of the component. Obviously, that can lead to components running too hot, and it can lead ultimately to die cracking and not only failure of the component, but failure of the equipment the component is in. So X-ray becomes a bigger and bigger part of what we're doing in terms of X-ray inspection and product performance.